Hello everyone! Today we will have a new lesson about binary arithmetic, addition, subtraction, multiplication, and division. In this topic of the binary tutorial, you will learn how to easily perform binary arithmetic such as addition, subtraction, multiplication, and division by hand. Binary arithmetic is one of those skills which you probably won't use very often. It can be very useful to know, however. These processes are often stepping stones to more complex processes which can do very powerful things. Fortunately, they are not too difficult, so with a bit of practice, you will be off and running in no time. Let's talk what is binary arithmetic. In mathematics and digital electronics, a binary number is a number expressed in the base 2 numeral system or binary numeral system, which uses only two symbols, typically 0 and 1. The base 2 numeral system is a positional notation with a radix of 2. Each digit is referred to as a bit. Because of its straightforward implementation in digital electronic circuitry using logic gates, the binary system is used by almost all modern computers and computer-based devices. Binary arithmetic is an essential part of various digital systems. You can add, subtract, multiply, and divide binary numbers using various methods. These operations are much easier than decimal number arithmetic operations because the binary system has only two digits, 0 and 1. Binary arithmetic is used in digital systems mainly because the numbers, decimal and floating point numbers, are stored in binary format in most computer systems. All arithmetic operations such as addition, subtraction, multiplication, and division are done in binary representation of numbers. It is necessary to understand the binary number representation to figure out binary arithmetic in digital computers. Binary additions and subtractions are performed as same in decimal additions and subtractions. When we perform binary additions, there will be two outputs, sum and carry. What are the arithmetic operations of binary numbers? First, the binary addition. Binary addition is the easiest of the processes to perform. As you will see with the other operations, it is essentially the same way you learned to do addition of decimal numbers by hand, probably many years ago in your early school years. The process is actually easier with binary as we only have two digits to worry about, 0 and 1. The process is that we line the two numbers up, one under the other. Then, starting at the far right, add each column, recording the result and possible carry as we go. Here are the possibilities. 0 plus 0 is equal to 0. 1 plus 0 is equal to 1. 1 plus 1 is equal to 2, which is 1 0 in binary, which is 0 with a carry of 1. 1 plus 1 plus 1, carry is equal to 3, which is 1 1 in binary, which is 1 with a carry of 1. The carry is involved whenever we have a result larger than 1, which is the largest amount we may represent with a single binary digit. It is a key for binary subtraction, multiplication, division. There are 4 rules of binary addition. For example, 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. Then, 1 plus 1 is equal to 0, carry over 1. In fourth case, a binary addition is creating a sum of 1 plus 1 is equal to 1, 0, wherein 0 is written in the given column and a carry of 1 over to the next column. For example, 0011010 plus 0001100 is equal to 0100110 or 38 in decimal. Let's try some examples of binary addition. Example number 1. 10011 or 19 in decimal plus 1110 or 14 in decimal. How to do the binary addition? 10011 plus 1110 is equal to, let's show the solution. 1 plus 0 is equal to 1. 1 plus 1 is equal to 0, carry over 1. Then 0 plus 1 plus 1 is equal to 0, carry over 1. Then next, 0 plus 1 plus 1 is equal to 0, carry over 1. Then 1 plus 1 is equal to 0, carry over 1. Then the 1 bring down. So the answer for the first example of binary addition is 100001 or number 33 in decimal. Next, for the example number 2 of binary addition, the given number is 11010 or 26 in decimal plus 10101 or 21 in decimal. The solution is 11010 plus 10101. The solution will be 0 plus 1 is equal to 1. Next column, 1 plus 0 is equal to 1. Next column, 0 plus 1 is equal to 1. Another column, 1 plus 0 is equal to 1. And the last column, 1 plus 1 is equal to 0, carry over 1, so bring down 1. So the answer for the example number 2 binary addition is 10111 or 47 in decimal. Let's proceed to the binary subtraction. With binary subtraction, we start to get a little more difficult, but not that difficult. Similar to binary addition, we will work through the numbers, column by column, starting on the far right instead of carrying forward. However, we will borrow backwards when necessary. Subtraction and borrow. These two words will be used very frequently for the binary subtraction. There are 4 rules of binary subtraction. Here are the possibilities. 0 minus 0 is equal to 0. 1 minus 0 is equal to 1. 1 minus 1 is equal to 0. 0 minus 1, we can't do, so we borrow 1 from the next column. This makes it 1 0 minus 1, which is 1. So here are the 4 rules. 0 minus 0 is equal to 0. 1 minus 0 is equal to 1. 1 minus 1 is equal to 0. Then 0 minus 1 is equal to 0. Borrow 1. Borrow 1 is required from the next higher order bit to subtract 1 from 0. So the result becomes 0. For example, 0011010 minus 0001100 is equal to 0001110 or 14 in decimal. So let's show for the solution. For example, number 1 of binary subtraction, the given number is 11100 or 28 in decimal minus 1010 or 10 in decimal. The solutions will be 11100 minus 1010. For the first column at the right, 0 minus 0 is equal to 0. Next column, 0 minus 1 cannot be, so we borrow 1 from the next column. Then 10 minus 1 will be 1. Then the next column, which is 1, will be 0. Then 0 minus 0 is equal to 0. For the fourth column from the right, 1 minus 1 is equal to 0. Then bring down 1. So the answer for the binary subtraction example number 1 is 10010, which is 18 in decimal. If we have multiple zeros in a row on the top number and need to borrow, then things get a little interesting. It follows this general process. Sometimes you may have to do this over multiple columns, but the process is the same. Let's say we have 100 minus 1. In the first column, we need to borrow a 1, but the second column is 0. Column 2 borrows a 1 from the third column and becomes 10 or 2 in decimal. Now, we may borrow 1 from the second column, decreasing it from 2 to 1 or from 10 to 1. Now, column 2 is 1 and column 1 is 10, and we may continue as normal. Let's proceed for the binary subtraction example number 2. The given number is 10000 or 16 in decimal minus 1111 or 15 in decimal. The solution will be 10000 minus 1111. 1 can be 0, then 0 become 10 for the borrow. Then proceed the subtraction. So 0 becomes 10 minus 1 is equal to 1. Then 1 minus 0 or then becomes 10 because of the borrow 1. Then 1 minus 1 is equal to 0. To the third column from the right, from being 0 becomes 10 and then borrowed by another column, it will be 1. 1 minus 1 is still 0. For the fourth column, another 10 because of the borrow 1, then became 1. 1 minus 1 is equal to 0. And for the fifth or last column, 1 becomes 1 because it already borrowed 1 from the other column. So 0 minus no numbers, just bring down 0. So the answer for the binary subtraction example number 2 would be 0, 0, 0, 0, 1 or 1 in decimal. For another approach, the above example is the most convenient way for us to do binary subtraction by hand. There is another approach, however, in this is the way that computers subtract binary digits. This approach is called 2's complement. Let's say we want to compute 1, 0, 0, 0 or 8 minus 1, 1 or 3. Step 1, write the equation out, padding the bottom number with zeros. So 1, 0, 0, 0 minus 0, 0, 1, 1. Next, step 2, invert the digits of the lower number. 1, 0, 0, 0, then 1, 1, 0, 0. Step 3, add 1 to the lower number. 1, 0, 0, 0, then 1, 1, 0, 1. Step 4, add those two numbers together to get 1, 0, 1, 0, 1. Then step 5, remove the leading 1 and any zeros after it. You are left with 1, 0, 1 or 5. Let's talk about binary multiplication. Binary multiplication is just about as easy as binary addition. Again, it is the same process as you would do with decimal multiplication by hand. Again, it is easier as binary only has 0 and 1. We line the two numbers up, similar to addition. Then we multiply the entire top number by each individual digit of the bottom number. As we move across each digit, we pad out the result with zeros to line it up. Finally, we add all the results together. Here are the possibilities. 0 times 0 is equal to 0. 0 times 0 is equal to 0. 1 times 1 is equal to 1. Binary multiplication is similar to decimal multiplication. It is simpler than decimal multiplication because only zeros and ones are involved. There are 4 rules of binary multiplication. First rule, 0 times 0 is equal to 0. Second, 0 times 1 is equal to 0. Third, 1 times 0 is equal to 0. And the fourth rule is 1 times 1 is equal to 1. Multiplication is always 0 whenever at least one input is 0. For example, 0, 0, 1, 1, 0, 1, 0 times 0, 0, 0, 1, 1, 0, 0 is equals to 0, 1, 0, 0, 1, 1, 1, 0, 0, 0 or 312 in decimal. Let's try binary multiplication example number 1. The given number is 11011 or 27 in decimal times 10 or 2 in decimal. The solution is, first multiply the first column from the right. 0 times 1 is equal to 0. Next, 0 times 1 is equals to 0. Then next, 0 times 0 is equal to 0. Next, 0 times 1 is equal to 0. And last, 0 times 1 is still equal to 0. Then, next, since it is almost or all are 0, then pad out. Let's proceed to the another number. 1 times 1 is equal to 1. Then next column, 1 times 1 is still equal to 1. Next column, 1 times 0 is equal to 0. Then 1 times 1 is equal to 1. Then last column, 1 times 1 is still equals to 1. Then add together. 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 0 plus 1 is equal to 1. 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. Then bring down the remaining number from the last column, which is 1. So the answer of, or the product of 11011 times 10 is equal to 110,110, or 54 in decimal. Let's try again. For example, number 2, the given number is 11111 times 101. The solutions will be from the first column to the right. 1 times 1 is equal to 1. Next, 1 times 1 is equal to 1. Next column, 1 times 1 is equal to 1. 1 times 1 is equal to 1. And the last column, 1 times 1 is equal to 1. Then next, proceed to pad out. Then proceed to the next number. 0 times 1 is equal to 0. 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 And for the last column, 0 times 1 is still 0. Next, proceed to the third number, then pad out. 1 times 1 is equal to 1. 1 times 1 is equal to 1. Next column, 1 times 1 is equal to 1. Next, 1 times 1 is still 1. And for the last column, 1 times 1 is equal to 1. Then add together. 1 plus 0 plus 1 is equal to 1. Next column, 1 plus 0 plus 0 is equal to 1. 1 plus 0 plus 1 is equal to 0, carry over 1. Then 1 plus 0 plus 1 is equal to 1. Then next column, 1 plus 0 plus 1 is equal to 1. 0 plus 1 is equal to 0. Carry over 1. Then 1 will be 1 for 0. So the product of 11111 times 101 is equal to 1001111, or 155 in decimal. As you have no doubt noticed, the process is fairly straightforward. If the binary digit on the second row we are multiplying by is a 1, then pad out accordingly and write out the top binary number. If the binary digit on the second row we are multiplying by is a 0, then we can just write out zeros. If we want to multiply a binary number by another number, which is a power of 2, then all we need to do is add the number of zeros representing that power to the right of the first number. Example, 8 is 23, which is 1000 in binary. So 101101 times 1000 is equal to 101101,000. Let's talk about the binary division. Binary division is probably the most difficult of the binary equations. Fortunately, it is also made easier by the fact we only have to deal with ones and zeros. First off, some terminology. The number we are dividing by is the divisor. The number we are dividing into is the dividend. The process is as follows. Step 1. Create the working portion of the dividend. Starting at the right, keep including digits until we have a number that divisor will go into. Step 2. Work out how many times the divisor goes into the working portion with binary. This is easy as it will always be 1. Write this number above the line, in line with the far right digit of the working number. Step 3. Subtract the divisor from the working number. This becomes the beginning of the new working number. Step 4. Bring down digits from the dividend and add to the new working number until we have a new working number large enough for the divisor to go into. Step 5. Repeat steps 2 to 4 until we are at the end of the dividend. Step 6. The result of the final subtraction is the remainder. Binary division is similar to decimal division. It is called as the long division procedure. There are 4 parts in any division: dividend, divisor, quotient, and remainder. The result is always not defined whenever the divisor is 0. So for example, 0 divided by 0 is not defined. 0 divided by 1 is 0. 1 divided by 0 that's not defined. And 1 divided by 1 is 1. So like for the example, 1, 0, 1, 0, 1, 0 divided by 0, 0, 0, 1, 1, 0 is equal to 0, 0, 0, 1, 1, 1 or just simply 1, 1, 1. Let's try the binary division example number 1. The given number is 1, 0, 1, 1, 1 or 23 in decimal divided by 1, 0, 1 or 5 in decimal. The solutions will be: take 1, 0, 1 divided by 1, 0, 1 is equal to 1. 1 times 0, 1 is equal to 0. The next column, 1, 0, 1 minus 1, 0, 1 is equal to 0. Bring down 1, 1. So, 0, 1, 1 divided by 1, 0, 1 is equal to 0. So 0 times 1, 0, 1, then the remainder will be 3. So the answer for the 1, 0, 1, 1, 1 divided by 1, 0, 1 is 1, 0, 0, remainder 3. Let's try the example number 2. The given number is 1, 0, 1, 0, 0 or 20 in decimal divided by 1, 0 or 2 in decimal. The solutions will be 1, 0 divided by 1, 0 is equal to 1. 1 times 1, 0 is equal to 1, 0. Then 1, 0 minus 1, 0 is equal to 0. Bring down the next number, which is 1 and 0. Then 0, 1, 0 divided by 1, 0 is still 0, 1. Then 0, 1 times 1, 0 is equal to 1, 0. 1, 0 minus 1, 0 is equal to 0. So the answer or the quotient for the binary division example number 2 is 1, 0, 1, 0, remainder 0. For the answer of 1, 0, 1, 0, 0 divided by 1, 0. So that's all for the lessons or discussions about the binary arithmetic such as addition, subtraction, multiplication, and division. Thank you for watching and have a nice day.